Lesson 3's homework is going to be translations on the coordinate plane. So we're working on sliding our shapes around the graph based on what our rule is going to be. For the first one, for triangle ABC, we'll start by graphing it. We've got A, 1, 1, B, 2, 3, and C, 3, 4, 5, 6, 1, 6, negative 2. So there's triangle A, B, C. And we'll connect it to make sure that we have a triangle. Our next piece is going to be, we're going to translate it by the rule x minus 2, y minus 6, which means we're going to go left 2 and down 6. So we'll take each point and just count. Left 1, 2, 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 3, 4, 5, and 6. And there's all of our prime letters. And again, we'll connect them to make sure that we have a triangle. And then the last piece it wants us to do is we're going to draw a vector. And our vectors have distance and direction. And I'm just going to take an extra second here to put arrows on the end of these to make sure that we're clear which way our original points are and which way our image points are. Remember, a vector always starts at the original point and is the length of the distance between the original and the image, always pointing at the image. For our second question, we have a line segment, AB, and A has been translated to form A prime, and we want to do the same thing to B. So first we need to find the slope between A and A prime. So it's up 3 and over 1, 2, 3, 4, 5, 6. So we need to do the same to B then. We have to go up 3 and over 1, 2, 3, 4, 5, 6. And there's going to be B prime. I'm going to make a line segment. Oops, still on my vector function. So we'll make a segment connecting A prime and B prime. And it wants us to, first, I'll write down the points for B prime. So B prime was 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 1. And what's the relationship between the two segments? And what we end up with is there's two features. Okay, they are equal distance and they are parallel. And the reason is because a translation is a rigid motion which preserves size and shape. So because a translation is a rigid motion, those line segments are going to remain the same length, and they're also going to remain parallel. In the third one, a translation maps negative 411 onto 1810. Determine the coordinates of the image. Well, the first thing we have to do is figure out what the translation was. Well, to get from negative 4 to 18, we have to add 22. And to get from 11 to 10, we have to subtract 1. So the translation overall that was applied here is capital T and then 22 comma negative 1. So if we do that same translation here to that next point, 5 and 22 is going to give us 27, and negative 7 minus 1 is going to give us negative 8, and that's going to be our image of that new point. State a property of translations that is not a property of reflections. So the key is orientation is not preserved. Or orientation, is not preserved in reflections, but is preserved in translations. And if we remember, reflections were opposite isometries, meaning equal size, but different orientation of the letters, and a translation was a direct isometry, meaning that not only was the distance and the shape preserved, but so was the orientation. And our last one, triangle LIT is graphed on the axes below. Determine and state the coordinates of triangle L prime, I prime, T prime, the image of LIT after a translation, x minus 3, y plus 6. So we're going left 3, and we're going up 6. So T, 1, 2, 3, 1, 2, 3, 4, 5, 6. There's T prime. Now notice, I'm just going to point out too, it says state the coordinates, so we have to make sure that we are going to write down the actual coordinates of all these before we finish. I, 1, 2, 3, 1, 2, 3, 4, 5, 6. There's I prime. And L prime doesn't look like it's going to fit. 1, 2, 3, 1, 2, 3, 4, 5. And we're going to put the 6 there. So I'm going to erase where I wrote up 6. I'm going to move that a little bit. And then 1, 2, 3, 1, 2, 3, 4, 5. It's actually going to be 2 rows above for L prime. So the coordinates of L prime is negative 1, 2, 3, 4, 5, 6. And it's going to be up to 12. T prime is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Actually, I kind of went too far. So it's going to be 5, 7. And I prime is 1, 2, 3, 4, 5, 6, 7. So negative 7. 1, 2, 3, 4. So negative 7, comma 4. We'll connect those to make them into our new triangle. And you should see all corresponding sides are the same length, as well as all corresponding sides are parallel.